I would like to introduce our next speaker, Emma Greenhatch. She is communication manager with Pyrocal. So Pyrocal creates a super interesting high-tech equipment that creates energy from waste. Can you tell us a little bit more about that?
Thank you very much, Garana, and thank you so much to Jeff for the invitation to be on this panel today. I'm going to focus on the circular carbon economy in my talk and how Pyrocal is helping to develop it. So who is Pyrocal? We are a company located in Toowoomba, not too far from Brisbane, privately owned. We've been going for 10 years now, and we design and manufacture industrial scale biochar systems. Show of hands from the people here, who knows what biochar is? Well, most of you, but there was a few that didn't put your hands up, so I'll give you a very quick definition. It's essentially a form of charcoal, but unlike the charcoal that you get in your campfire, biochar is produced when you burn biomass in an environment that's got limited or no oxygen. I'm going to show you how the process works in a minute, but before I do that, I want to take you on 3 different journeys. And what I'm going to ask of you when we go on those 3 different journeys is that you imagine that you're a macadamia nut shell. You probably want to be a macadamia nut, but you've got to be a macadamia nut shell. So we're all starting in the same place on a macadamia tree up in Bundaberg, about 6 hours north of here. Journey number 1, you're harvested from the tree. You get taken to a processing facility locally in Bundaberg. Nut gets extracted, shell gets put into a shipping container, onto a truck, down to the port of Brisbane, onto hopefully one of those green vessels that we heard about on Wednesday, but probably not for a while yet. You head off to Europe, to Germany, you get burnt and turned into energy. Journey number 2, you get harvested, put in a shipping container, on a truck, down to the port of Brisbane, get shipped off to China, processed in China, nut extracted, and then you get burnt. End of story. Journey number 3, you get harvested, you get taken to the local processing facility in Bundaberg, nut extracted, you get put in a shredder that's co-located with the facility, chopped up into lots of little pieces, and then you get put into a Pyrocal continuous carbonisation technology, CCT for short, system. I'm going to show you now how that works. I'm not an engineer, so if there's any technical questions, we have a great team of engineers who will be more than happy to answer it for you, but I'm just going to give you my version. So that nutshell gets fed into this hearth on the left. I need a pointer too, Scott. And that has lots of different decks in it. The temperature in there ranges from 500 to 750 degrees, so it's really hot. Important to note, there's a little bit of air that we put in there from that fan at the bottom, and that makes our process different to a pure pyrolysis process, which has no oxygen in it. And by putting a little bit in, that means that we get more heat out of our process, and we can capture more heat and therefore more energy. About 100 seconds going through all of those decks, and the volatile compounds get separated from the physical mass, and the biochar comes out the bottom. I'm not going to talk too much about everything that happens to the right of that hearth, but to say that is all around the energy recovery, the heat recovery, to be able to turn it into energy, and also to clean up those off gases so that the steam that comes out the end is usually cleaner than the air that it goes into. So it's all about emissions and energy control. So you can see the biochar production piece is very small, and the rest of it is all around emissions and energy. So what do we do with that biochar when it comes out? Well, we have to give it a shower, because if we didn't, it would probably combust, and then we'd have CO2, and that would be bad. So we quench it, and then let's imagine then it goes straight back to the property that came off. Gets mixed with some goodies like compost, and then gets put back underneath that tree that it originally came from. And then it becomes macadamia biochar superstar. Why? Few reasons. It's like a giant sponge, so it holds water. Really important in dry conditions. not like that here today, but when it's dry, really important. It also has a really open cell structure, so it's fantastic for microorganisms, good bugs, which we know we need a lot more of to increase our soil health. Like it holds onto water, it holds onto nutrients, makes them more available to the plant. And last but not least, it's around 85% carbon in a very durable form. So if that nutshell just decomposed on farm and delivered benefits back to the soil, but naturally occurring CO2, this holds that carbon for hundreds of years. So the grower's happy because not only has the shell protected the nut, but also there's benefit back to the tree. The processor's really happy because they've been able to sell the biochar back to the grower. They've been able to produce renewable energy and reduce their fossil fuel consumption. And they've also been able to produce biochar carbon credits. Biochar production is widely regarded as one of the most promising technologies at the moment for emissions reduction. 1 tonne of that biochar produced from macadamia nut shell removes 2.5 approximately tonnes of CO2. At the moment, from our facility in Toowoomba, we are producing nutshell biochar and also associated carbon credits, which are certified by Puro Earth, which is owned by Nasdaq, located in Finland. We're currently getting $150 per tonne for our biochar carbon credits, and I could sell biochar carbon credits all day, every day if I had them. So I'm going to take you. Oh no! Oh gosh! Oh, don't give me the clicker. Which way am I going? No, is that you? Where am I? Oh, now I'm not even doing anything. No, that's it. Yep. Okay, that one. So there's so much more to say, but I'm out of time. But I just wanted to leave you with this circular carbon economy diagram. So in Australia, we produce huge quantities of waste biomass from agriculture and also from forestry. And we're deriving very little value or benefit from that. I hope from what I've shared with you today, you can see how biochar production can help accelerate a circular carbon economy. And I'll throw the question to you, which journey would you rather be on? Thank you.